A main objective of the entire lean production effort is the concept of flow. Ideally, production should flow continuously all the way from raw materials to the customer. Envision realizing this ideal through a production system that acts as one long conveyor. In our case study, that would mean making the process flow from the supplier of raw materials to stamp, to press, to weld, to assembly, to shipping, and then out to the customer. Presently, our lead time is 10.25 days. The goal is to reduce this lead time. The theoretical minimum and our ideal is 76 seconds. Improvements to the present value stream will have to be made. A future state map will be drawn that takes into account the whole system and makes improvements where they are most needed. After brainstorming for improvements, the mock company produces the following future state map. A decision is made to bring some of the machines together in order to create a press, weld, and assembly cell. The machines are still in their natural order of processing and form the shape of a U. Cell operators may handle multiple processes, and the number of operators is changed when the customer demand rate changes. The U-shaped equipment layout is used to allow more alternatives for distributing work elements among operators and to permit the lead-off and final operations to be performed by the same operator. Another benefit is that inventory goes directly to the machine, rather than constantly moving inventory on and off a rack. Our original value stream map identified what is called a batch and queue production system. This means that we are producing more than one piece of an item and then moving those items forward to the next operation before they are actually needed there. Thus, items need to wait in a queue. This is also called a batch and push system. In contrast to this is the concept of a pull system. This icon represents a pull of materials, usually from a supermarket. This is an alternative to scheduling individual processes. Note how weekly schedules that were adjusted daily on the previous map for each of the stamp, press, weld, and assembly operations has now been replaced with just one daily ship schedule. This material icon represents a supermarket. Supermarkets are a controlled inventory of items that is used to schedule production at an upstream process. The number below the icon represents the number of pieces that must be maintained at all times. With a pull system, a downstream operation or customer process withdraws the items it needs from a supermarket, and the supplying process produces to replenish what was withdrawn. In order to achieve this, a Kanban or signal is used that gives instruction for the production or the conveyance of items in the pull system. This information icon represents a withdrawal Kanban. This is a card or device that instructs the material handler to get and transfer parts from a supermarket to the next process that needs them. In our case study, as shipping pulls a batch of 250 units, there is a vacancy in the supermarket that needs to be replenished with 250 more. The cell is signaled to produce 250 pieces and deliver them into the supermarket. In order for the cell to achieve this, it must pull its parts from another supermarket set up here. This next information icon is a signal Kanban that alerts the stamp operation when a reorder point is reached and another batch of 250 needs to be produced. Once produced, the supermarket is brought up to its quota of 1,000 pieces once again. Stamp pulls from this supermarket, and a withdrawal Kanban alerts materials to pull from the steel supplier. The information in our data boxes tells us that there is an increase in the yield. This results in a significant reduction in scrap. The cycle times and changeover times have been reduced as well. Note that deliveries have been increased to twice weekly and coil sizes are smaller. When we look at the lead time graph, we see that our lead time has been cut from 10.25 to 4.25 days. The actual value added time from the customer's perspective and our new theoretical minimum is 46 seconds. These positive changes are due to the overall efforts by the Mach company to improve their system. Once all of these improvements have been made, the value stream will be studied again in an effort to brainstorm for more improvements. One good example of a next generation improvement is to create continuous flow production. This means that items are produced and moved from one processing step to the next, one piece at a time. Each process makes only the one piece that the next process needs, and the transfer batch size is 1. This is also called a single piece flow or one piece flow. The benefits of such an improvement will be revealed in the next few sections of this course. Value stream mapping is a continuous process of improvement designed to try and reach the ideal. Although the theoretical minimum may never be reached, companies can continue to try and reduce overall production lead time. This in turn means the potential for more sales.
Preview, preview, preview. Preview, preview. Preview, preview, preview.